let's move to question number 3, the only geometry question in the paper. Read the question. Euclid has a tool called splitter which can perform two operations, only two types of operations. First is, given three non-collinear marked points x, y, z, it can draw the line which forms the internal angle bisector of x, y, z. So if you want to form an exterior angle bisector, the indication is that you will have to somehow mark a point and then get the exterior angle bisector. The second is, it can mark the point of intersection of two previously drawn non-parallel lines. So if there are two non-parallel lines, you can get the point of intersection. Nothing else is given. The question here is, suppose given three non-collinear marked points A, B, C, that means I have a triangle ABC and I am supposed to get the circumcenter of this particular triangle using this result. Now the initial thought could have been using 9-point circle, because the theorems are pretty much easy and relates directly and you can reach to some conclusion. The challenge here is that the midpoint that needs to be marked quite often in 9-point circle is not easily available, because have it been possible to mark a midpoint with compass as a perpendicular bisector? Why would have done this much of effort? We could have got the circumcenter of triangle ABC directly. So in order to get this question, we have only two tools. One is the angle bisector internal and the other is point of intersection of two existing lines. To understand it better how it has to be done, I'll take you to two lemmas previously which we had done in classes. One is, when we talk about angle bisector of a triangle, let me draw the circumcircle of triangle ABC. So if the internal angle bisector of angle A meets the circumcircle of triangle at a point P, then we make an statement loud and clear that PB is equal to PC. Essentially is also equal to PI if we intend to use I. So PB is equal to PC is equal to PI. The internal angle bisector when meets the circumcircle, the point with the other two vertices creates, and the logic is pretty simple. If you remember, this is A by 2, this is A by 2. So this angle and this angle, they both by angle chasing come out to be A by 2. So this is the first lemma that we are going to use. Simultaneously, if I talk about using the X circle and X center, suppose somehow I can draw both the internal and external angle bisectors. How? We will see in the diagram. But if I have IB as the one X center, IC as the other X center and IA as the third X center, so the internal and external angle bisectors are perpendicular to each other commonsensically. So I realize that this angle is 90 and this angle is 90. So that would simply mean that the quadrilateral ICIBCB is cyclic with ICIB as diameter. So I try to use this fact, and how do we do that? Let us see. So I draw a circle passing through I3, and we remember this fact that ICIB, basically this is cyclic. More than cyclic, if we can get any other result, we will look into that. But yes, this much is safe, and this basically is the diameter of this circle. With these two results, we would try to establish the question, two lemmas, and both are pretty easy to digest. So let's proceed here. Since this is a representative diagram, so I would just go with the diagram easy and then come back. At the first step, I will draw three angle bisectors, internal angle bisectors, because we have the tool, and get the in-center I of the triangle ABC. Once again, the diagram is representative, so don't go by that. You were supposed to write the steps in the exam. So I have this. Now the challenge is, I want to draw X center of a particular triangle, and that particular triangle is none other than triangle BIC. But I have a challenge here. I can draw only the internal angle bisectors. I cannot draw the external angle bisector because I don't have a point. So in order to get those points, we will do some sort of geometric bashing. So let me take, now focus on this triangle, right? My first intention is to get a point here on extended BI so that somehow I can draw the angle bisector of exterior angle bisector. But since I don't have a point, so what I do here is, let me take a light color to work on this. I draw the internal angle bisector of the IBC, or maybe any other internal angle bisector which we have. So suppose if I draw such angle bisectors of this particular angle bisector, ABI, I get a point of intersection, let me name it as X, on CI extended. The role of this internal angle bisector was only to take me to X, that's it. Similarly, I will draw another angle bisector and get Y if needed be, although we are very much clear that now I have XIB as an angle, and with the tool I can draw the internal angle bisector of angle XIB like this. Now imagine a situation, you have this internal angle bisector of ICB and this internal angle bisector of IBC, because the tool is with you. So you get these two IB and IC, in fact it should be otherwise, if to be more precise, IC and IB as two excenters, but of which triangle? Triangle IBC. If this goes correct, then if I join IC with B and IB with C, I realize that I have a cyclic quadrilateral. We need not join also, let's not join. We have a cyclic quadrilateral, and what is that cyclic quadrilateral? IC, IB, C and B. Remember, in the lemma we had taken this thing for triangle ABC with IBIC as diameter. Here we are doing the same thing for IBC, IBIC as diameter. So there has to be some circle which passes through these 4 points, and that basically is not the circumcircle we are trying to find. Since the diagram is representative, to just bear with me, we have to go with this representative diagram somehow, that these 4 points are cyclic. Now let me bring it down and squeeze a bit so that you get the full picture. Right. So now if this is the situation, I have these 4 points cyclic. We can manipulate the diagram, but not necessarily at this stage. Right. I would take it a bit shorter, because let it be something like that. And let this line be a bit. So this is how it would look like. Fair enough? Yeah. Now how do we get some help from this is somewhat critical. This is IB, this is IC, and this is the diameter of one circle, which definitely is not your circle of choice, because your circle was of triangle ABC, but we haven't reached there. So let it be. Now how do we proceed from this point? What we do is, we see that there are two right angles. We see that there are two right angles, one when I join IC with B and one when I join IB with C. So I have two right angles, because for sure this is the diameter. So this angle is 90 and this angle is 90. I intend to draw the angle bisector of these right angles. Only intent is that somehow I should reach to a point, but I know very well that IC, IBB, the circumcircle is this very circle and IC, IB is this very circle. So, but obviously both these would basically intersect at a point, same point on the circumcircle, which has to be the midpoint of this arc, or ideally this triangle is isosceles. Let me call this point as P. So, we should understand that P, I, B, I, C is an isosceles triangle. The logic is this very lemma. For a triangle, if the angle bisector goes, this particular triangle is isosceles. So I come back with the same result. I have a triangle. I can shade it better for you to have a good look. So one is this particular triangle, right angle triangle. If I draw the angle bisector, it goes on the circumference at a point P, and another is basically this particular right angle triangle. If I draw the angle bisector, it goes on the same point P, and it has to go because the quadrilateral is cyclic. So I have this particular isosceles triangle. But P, IB, IC is isosceles. Unfortunately, PBC is not isosceles. So we cannot proceed from this point. What we are trying to do, what is the intention behind this? We either want two diameters of circumcircle of triangle ABC or two perpendicular bisectors of triangle ABC. Both of them will help like anything. So diameter, if it is not possible, I wanted to see the perpendicular bisector of triangle ABC, but now I have a point which is on the circumference of this very circle with B and C also on the circumference. Last stroke, if with the same lemma I drop the angle bisector of angle PBC, I will highlight it for you. If I drop the angle bisector of angle PBC, by the lemma itself we conclude that if this is the angle bisector and it intersects the circumference at point Q, then QBC is isosceles. That means I drop QBQC is equal. Same lemma. Remember, PBC is not isosceles, so you may not get any direct result. But whatever is triangle PBC, angle bisector of angle BPC when meets this circumcircle at Q, this triangle is isosceles. And then doing nothing but a formal working, draw the angle bisector of QBC. Since the triangle is isosceles, let this point be M. So QM is perpendicular bisector of side BC. We are done. The moment I draw the angle bisector of triangle PBC with P as the angle BPC, it meets the circumcircle at Q. This circumcircle is not your desired circumcircle, but whatever be the circle, triangle BQC is isosceles, and it helps me in solving the problem. For the angle bisector of an isosceles triangle is also the perpendicular bisector. So that means we have got the perpendicular bisector of BC. Similarly, this is what you were supposed to write, get perpendicular bisector of any other side, say AB, and when they intersect, that exactly is the circumcenter of triangle ABC. So I will summarize what we have done again. We have started with two lemmas which are basically very primitive and very direct, but not so easy to remember, that IBIC is diameter. So what we did here is we started with our working on the triangle ABC. We had just completed in center, then got a point on these extended side using any other angle bisector X and Y, and then get the exterior angle bisector of this triangle. So we had put everything on focus on triangle BIC. So this angle bisector, and when these two internal angle bisectors intersect here, I1 and I2, we realize that this basically is the diameter as per this very lemma. I repeat, we get the internal angle bisector directly and exterior angle by this point. Now with this lemma, we realize that if we draw these two angle bisectors, we get a point P on the circumcircle of ICBCIB, and then we proceed for PBC, we get a point Q and one of the perpendicular bisectors followed by second. The point of intersection of these two perpendicular bisectors is the circumcenter of triangle ABC. The only way you can get through this is through these two lemma. An excellent question to test your patience and overall understanding of geometry.